Well, welcome everybody. Thanks for joining me on this video. What we're going to do here is replace the bearings and otherwise freshen up a small electric motor. This one in particular is 1 horsepower, but the steps I'm showing here are good for anything from, say, a 0.5 horsepower motor up through about 3 horsepower. Beyond that, the 5 horsepower range, things are a little bit different. Maybe not quite as applicable there, although the general principles are the same. Now, the motor I'm using here is a Baldor brand motor. Baldor is a great name. They've been in business for, I think, over 80 years. Made in the USA. However, it doesn't, it's not that important what brand I'm using. This is the same if you got, say, a Leeson motor or a Dayton motor or some other electric motor. The ideas are basically the same. How you get the bearings on and off, checking the start capacitors. We'll talk about what that is. Checking your switches inside. This is not rocket science. You can do it. Just takes a little bit of patience and a little bit of elbow grease. So if you could stick around, watch this. Hopefully you will get some good ideas on repairing and replacing the bearings and touching up and refreshing your own electric motors. So let's get started. All right, what you're seeing here is that Baldor motor that we're going to use to rebuild. This is a 1 horsepower motor, so it's on the smallish side, medium size, I guess I'd say. We're going to start it up in a second. I'm going to show you what it sounds like when it's running. This has bad bearings in it. That the grease in these bearings left the room long ago, so it's pretty squeaky, pretty noisy. We're going to rebuild it. I just want to show you what this sounds like at the start so that if you're having the same problem, you'll be able to identify it. And we'll just get this thing torn open. So let's take a look, fire this up and see what it sounds like. And before we get started tearing the motor apart, I should give a public service announcement here on the importance of buying name brand good bearings. The bearings are the only moving part really in the whole motor. This is where the wear and tear occurs. And this is what we're going to focus our restoration efforts on. If you replace the bearings in a motor, basically, you've got a motor that's at least 90% back to new specs, so it's important that you get that done and you get it done right. You can buy cheap bearings from China. You can go on eBay or wherever else and get, say, a 10-pack of bearings for $25. That's, in my opinion, that's kind of ridiculous. We're going to see how much it takes to open up a motor, pull off the rotor, get the bearings out, pull them off, tap new ones on. If you're going to go through all that effort, you should really spend just a few dollars more and get good name brand bearings. Otherwise, you run the risk, if you use cheap bearings, of having to redo this in a year or a few months or whenever, depending on how cheap the bearings are you put on and how much you're using the motor. So if you get good name brand bearings, you can go for years with this motor as is without having to touch it again. Name brand bearings include companies like SKF. They're based in Sweden. Timken, if you're in the U.S. Plenty of good Japanese manufacturers out there. Nachi, NTN, NSK. Those are the good names that come to mind. You can get them, different suppliers. I believe eBay. I get mine on eBay oftentimes. Again, you're going to spend literally a few dollars more for a good name brand bearing versus the no-name junk ones. Save yourself the trouble. Get something good. Get a good name brand bearing, and you should have no trouble at all. Okay, I'll get off my soapbox now, and let's get back to taking the motor apart and rebuilding it. Before we take the motor apart, let's plug it in and run it for just a moment so we get an idea of what it sounds like before, and then when we're done at the end of the video, we'll plug it in again and get the after sound. I think it'll be pretty surprising the night and day difference you get when you put in some fresh bearings. So let's try that out really quickly here. All right, let's plug this thing in and see how she sounds. And here we go. 3, 2, 1, and 0. Wow, yeah, that's pretty noisy, all right. Notice how it continues to spin, keeps going. Wow, look at that go. Let's put a stop to that as soon as. Yeah, that's pretty noisy, all right. And notice how it kept spinning. That's usually a sign of a bearing without much grease in it. If you've got a better motor, this will stop spinning down within a few seconds. That could have kept going for a minute or so. And you heard that high-pitched sound. Bearings are definitely just about at the end, if not already at the end of their life. So it's a good thing. We're going to take this thing apart. Again, we're going to give it the old new lease on life. We're going to take this outside, get a little better light, and we'll start whacking this thing open. All right, the first order of business is to take the through bolts out from the motor. This one in particular has 4 of them. You notice I'm pointing 1, 2, 3, and then 4 at the lower left there. The through bolts on this are about a foot long, I guess, maybe a little longer. Just get a couple of ratchets. This shouldn't be hard to do. You don't need any power tools for this. Take your ratchets, put them on opposite sides, and just crack this thing open, as we're doing here, if we can get things lined up properly. There we go. No rocket science here. Just get the get the bolts off, and then we're going to take the through bolts out, and we'll be ready for the next step after this, which is to take the, well, assuming we don't drop the ratchets, of course. The next step then would be to crack the end bells off, and we'll show that in just a second. All right, we got the bolts out finally, those through bolts. Not too difficult. Sometimes they can be a little bit sticky to get out, but in this case we did fine. Notice too, when I take those things out, I immediately put the bolts back on top there, screw them back in. That way there's no chance of losing them, you know, if you put this project aside for a week or two. So no loss there, which is a good thing. If there are loose bolts around or there are loose hex nuts around, guarantee you I'm going to lose them if there's any possibility of that. So just put them back on there when you're done, and then you'll be in good shape. Now when we do take this apart, what we're going to want to do is take a small screwdriver and tap on those little tabs you see on the left and the right there. Get the screwdriver, put it in there, those little tangs you're seeing there. Take a small hammer and just start tapping these two end bells apart, the left and the right, just like that. Easy, gentle taps. Make sure you hit it at a proper angle, high enough angle. You don't want to come in too shallow on this thing like that, because you can wind up slipping. Also, you don't want to hit it too hard when you do this. Gentle taps. You go too hard, you're just going to wind up slipping the screwdriver off there and just, you know, making a mess, skipping and skimming your knuckles. You don't need that. So again, just nice gentle taps. This will come apart. Use a small hammer of some sort, and we'll get this thing apart in just a second. All right, before we pull this thing apart, let's get the start capacitor out of the way. Bulge on the top that I'm pointing to with the screwdriver. That is sort of the starter motor for your motor, if you can think of it in automotive terms. That provides a little juice at the beginning to get things spinning. Right now it's in the way. It's got a couple of lines going, a couple of wires going from it to the end bell on the left. So it's a good idea to get this out of the way rather than take a chance when you knock this stuff off the end bells, you wind up pulling those wires. So there are 4 screws there, not too hard to get off. We'll take care of that, get those things out of the way, get the start capacitor out of the way, and then we'll continue. So let's do that. All right, well, we got those 4 screws out. You can see the start capacitor at the top there. Yes, the 4 holes there, they're the screws. What we're going to do is, as we did with the through bolts, as soon as I'm done with this video, I'm going to put them back on there, just like I did with the through bolts, or put the screws back in their holes. Again, the principle is keep them where they were before. That way there's no chance you're going to lose them later on. At least that works for me fine. I don't know about you. In the meantime, we're going to take a look at this start capacitor. You can see up there, unfortunately, it's black on black, so it's a little hard to see, but it's a cylindrical thing. You can get these pretty cheap. I'm going to replace this one. This one was probably $10 or $12 to replace, so not a deal breaker, really. It's made of hard plastic if you haven't seen them before. And you can see at the bottom there are 2 wires that go into the end bell. From there into the end bell. All right, let's focus on the start capacitor for just a second. Now, you've got several things on this. You've got the hertz on this, which is 50 or 60 hertz. That's standard. This one has 125 volts rated for, and you want to pay attention to that. And also the microfarad rating, which in this case is about 640 to 770. They always come in ranges like that. Take a look online, find something that is as close as possible that you can get to this, and you should be fine with that. Let's chat for a moment about the start capacitor just a little bit more. I've got it out of there. That was fine. It was a little bit of a tight fit. It fits in pretty tightly there. And it came out, unfortunately, there's a little crack forming on the top. You can see that right in there. Well, that's to be expected with this hard plastic. Like I said, we'll replace it. $10, $12, not a big deal. It still works, but still, it never hurts to replace these things. So you can see it's got some specs on there. We'll take a look at that in just a second here. Focus in on those things. You've got the microfarads. You've got the voltage, and you've got the hertz. So let's take these guys in turn here. So the first one we want to look at is the hertz there on the lower left where I've got highlighted. 50 to 60 hertz. That's perfectly standard. When you buy one of these capacitors, that shouldn't be a problem finding something like that. So I wouldn't worry too much about matching those specs. The next one up would be the voltage. And over on the right where I've got that highlighted, you can see that reads 125 volts, the VAC bit. That you can fudge a little bit. You want to get something that's at least as many volts as you've got in this or more. So in this case, 125 is fine. You can also get something, say 250 volts. They usually go in increments like that. They jump from one voltage rating to another. So anything at the level you've got and above. So that's fine too. Again, there's a little fudge factor involved with that. Now what you've got to stay very close to, however, are the microfarad readings. That's the stuff I've got highlighted over on the left here where it says 645 to 774. The UF stands for microfarads. That, when you're buying a capacitor, you want to stay as close to that range as possible. That determines the running characteristics, for lack of a better phrase, of the motor. So you don't want to mess around with that. You want to get something that's just as close to that. So again, you've got the hertz, which in this case is 50 to 60. Shouldn't be too hard to find. The voltage, which again, in this case is 125. You can get that or more. So 125, 250, something like that. That's fine. You don't want to go too crazy. Try to get the next level up. But what you want to pay special attention to is that microfarad reading. Again, in this case, 645 to 774. When you're buying a new capacitor, focus on that. That's what you want to stick with. All right, you'll notice I put a little tape over the tangs that we're going to be whacking on with the screwdriver. I did that just to keep any scratching to a minimum. You don't have to do that, but it's just good practice in my view. That way you're not taking off more paint than it's already missing. So it's just good practice in my view to do that. We'll start tapping it off in just a second. Again, nice easy taps, and you'll get this stuff loosened up. All right, we did our tapping. We've got these bells loose. I took a little sledgehammer and screwdriver there and just tapped on those tanks. Nothing hard. I didn't go crazy or anything like that. It doesn't take much to get these things loose. Now they're loose. The bearings are still in there, which is why they're not coming out all the way. And we want to be careful. We want to keep whacking at this point. Once you get them loose like that, you start wedging them out a little bit. That's the goal. Take a screwdriver like that and just turn it. I'm not pressing it in. I'm just turning it, opening that gap in various locations, picking this spot, that spot, opening it up a little bit. If you need more room, get a pry bar out and open it up with that. Again, turning it, not pressing it. And you'll get this thing out eventually. Just got to stay patient with it. And on this end bell here, you got to be a little bit careful. You got the wires going into it. We'll show the connection in just a second. This, you want to be careful when you pry it off. Those wires have to thread through that hole eventually. And again, you don't want to go crazy whacking those things out and wind up pulling the wires out incorrectly or loosening or wrecking the connection. You don't want to take a pry bar, for instance, just go wham, wham on that. Again, just nice, gentle, like we did before. Put it in the slot and twist it out slowly, and you'll be in business in pretty short order. All right, we twisted and turned, and now we've got one side out. You can see it down there at the bottom. Notice there again. Let's take a look. See the wiring there that goes to that little connection switch? That's a centrifugal switch. We'll talk about that in just a bit. But that's what I meant by not pounding on that as hard as you can, because the wiring going from there to the switch that's connected, in a fairly delicate fashion. You just don't want to, imagine pulling that bell off all the way and just tearing all that wiring out. You can have a lot of trouble if that happens. So again, nice gentle twist. You'll get it out. In this case, it worked out fine. And we'll talk about it in a sec. Here's the rotor you can see attached to that other end bell. Nice beefy thing. We'll talk about that a little bit. We're going to put a little varnish on there to clean that rotor up. We've got the fan there. You can see the bearings sort of in there that I'm pointing to. It's hard to see actually here. We're going to get that off. We're going to pull that. Once it's this loose, it's not that hard to get things off. Here's the bearing on the other end. You can see that right there. This is the heart of the matter. We're going to replace those two bearings, and if you do that, the bearings are really the only parts that have wear and tear. You can see that thing spinning, by the way, very loosely. Obviously, it's out of grease. We need to replace it. If we get the bearings replaced, you basically got almost a brand new motor, because again, those are the only parts that have any friction or wear and tear really to them. Electric motors are pretty simple as far as mechanical motion goes. So if you get the bearings replaced, you're in business, and we'll do that in just a second. All right, we got the other end bell off with a little pulling and prodding, nothing too bad. I just want to show you something here. Look how dirty this is. Wow, that's par for the course of these kinds of motors. Those big fins there, letting in all that air, well, that's also going to let in a lot of dirt and grime, which is fine. These motors are designed to take some of that stuff. It's just par for the course in the environment they're in. So we're going to clean all that up. We're going to sand down some of the grit. We're going to spray out using brake cleaner or whatever. We've got all the sticky dirt and grime and that old grease. You can see that green splotch in there. It's pretty ugly, but we'll take care of all that. That's, again, just part of refurbishing this thing. Now let's take a look over at the fan. Also, very quickly, take a look at the fan. Also very dirty too. And again, we'll clean that up. Again, not a big deal. There's the bearing there, and notice it's a little tired looking. It's green. Look how it spins too. That free spinning sound. It was also making a real nasty rattling noise. That indicates you've got a bearing that's shot. So it's just as good that we replace this thing. In this case, these are two different size bearings. This one's larger than the other side. Some motors will have the same size. It just depends on the size of the motor, how it's laid out. One thing we're going to talk about is using name brand bearings, so stick around for that. Well, before we go too much further, I want to emphasize the need for documenting all this as you're taking it apart. We've got a video here, which is great. That's great documentation. But for your own project, you want to take a lot of pictures, maybe do your own videos just so you know how things are oriented. So for example, here on this wiring, let's take a look at this. Notice how it fit in there. Notice we got the tab at the very top. And notice these fins facing downward. That's important. That makes this more drip-proof than otherwise. You want those fins facing down in case some water hits it, and it directs it away from the motor. Also, this tab that I'm pointing out is a dead center, so you want to make note of that. Also, look at the wiring here. Notice the black wire coming through the start capacitor into that tab at the upper right there. So again, you want to make sure you got that orientation right. These are tight fits in here. You don't want them spun around if you're moving. Notice how you can barely see, but the red wire at the bottom there sort of threaded underneath the stator. Again, make note of all these orientations as you're taking it apart. That way you can duplicate this when you put it back together. There's a method to this at the factory why they did it this way. You want to duplicate that method when you're putting this back together. Otherwise, it's not going to fit properly. Motor's not going to work right. You don't want to pulling wires out when this thing spins up. Who needs it? Just document this. A few pictures. That's all you need. Maybe a little, a short video describing things. And you'll be in business. All right, the wiring's been disconnected. You've got a centrifugal switch there. All motors basically have this that have any kind of start capacitor in them. First, we'll talk about the orientation of this. Again, important to document this when it comes out. That's how it looked like facing up when it came out of there. We got that tab at the top for orientation. Notice the connector there. That's about, 1 o'clock positioning. And so you just want to mark this down when you're taking this apart. That way, no surprises later. Essentially, this thing acts, there's a little ring there, and I'm doing a little Morse code typing. When it's pressed down like that, it completes the circuit and energizes the start capacitor. Or rather, the start capacitor is connected to the system, and it's able to spin things up. As that happens, some weights, as it spins out, some weights kick in and pull it away from there, and it breaks the circuit, and the start capacitor is no longer in there. Unfortunately, the visibility here is not very good. You can see where it connects there, where you could if there was some better light. But that's basically how this thing works. The start capacitor is energized to start with, and then as it spins up, it breaks that circuit, that ring we saw that we were pressing down, and then it's no longer energized, and the motor's able to go under its own momentum and from the wall energy, from the energy coming from the outlet. Let's take a quick second to look at the other end of the centrifugal switch. This part presses against it. That's providing the pressure against the ring to energize the start capacitor. Now, as the rotor spins up, you can see the little weights at the end of it. They spin up and they pull that ring forward, just as I'm doing right there. That breaks the circuit, and the start capacitor is then out of the loop, and the motor's running under its own power and from the wall socket. So that's fine, because start capacitors are only meant to run for a few seconds to start things up. Otherwise, they'll burn out. Now, in the meantime, as far as dirt and grime, we've got to clean out some grime here at the stator end. That's what the big magnet is that you're looking at right there. This is fairly dirty, not terrible. I've seen worse. We'll just clean it out a little bit. No big deal there. You want to keep this as clean as possible, of course, and you want to take care of it when you're cleaning it out. You're not pulling any wires out. So make note of that as you're doing this. Put a little simple green or maybe a little water on a shop towel and just clean that thing out as best you can. Blow it out with some compressed air, and you should be in business. And also take a look. The rotor, we're going to sand down the rotor a little bit with 1000 grit and then hit it with some varnish just to keep it clean. This rotor actually looks pretty decent, and you don't have to do that. You don't have to sand it down and varnish it. But if you have some laying around like I do and you want to do a more complete job, that'll work fine, but it's not necessary. All right, let's talk about getting the bearings off the rotor now. You see there are two of them there. I've got a puller on one side right there. That's my own puller. You can rent those at any auto parts store if you don't have one for free. Just return it within 2 days. You notice I've got a little notch there. That's where the puller sits. It has a needle end on it that fits into that groove and sort of centers things up. Then you can just fit it in, slip the jaws around the bearing, and then you take a wrench, as I'm showing right here, tighten it up, and then the bearing will come off. Make sure the shaft isn't spinning as you're doing it. That way you get some. That way you hold the shaft in place as you tighten, and then the bearing will come off. It'll take a little bit of work at the very first couple of turns, but once the bearing cracks, so to speak, once the friction's broken, it comes off pretty easily thereafter. So no big deal. Again, if you don't have one of these bearings, any auto parts store will rent it to you for a couple of days for free, just as long as you bring it back. All right, well, we better start cleaning out the end bells now. So we've taken them off. We got the bearings out. Now let's clean things up a little. Notice I'm putting on the thick, heavy-duty gloves. That's because we're going to be spraying a little bit of brake cleaner here in a second here. Notice I've already started. Kind of a dirty rag. That's how this goes. Let's take a look here. Cleaner than before, certainly, after a quick spray out with the with the brake cleaner. Also, I've got some automotive cleaner. This is called a surface cleaner. You may or may not have this stuff. You can get brake cleaner. You can use maybe some lacquer thinner or something like that. And there I've got the brake cleaner. So I'm doing a mixture here, just going back and forth to see what works best. Got to dig in there with the rags, with the shop towels, get all those fins cleaned out. There's no secret to this. It's just a matter of taking your time, getting into every nook and cranny you can, just cleaning it out. The cleaner the surface, obviously, the better the motor is going to work. So just take your time, go through doing all that, and you should be in good shape. Now for the really corroded bits, you get out a little sandpaper. Here I've got some 220 grit, which is mid-range sandpaper. You don't need anything too aggressive in here. 220 is fine, maybe 320 grit, something like that. There was a little corrosion on the fins, particularly some looked like almost like a calcium buildup of some sort. Just general corrosion. We're going to take care of that. Again, just getting into every nook and cranny. No secrets again here. Just going through slowly, working through the corrosion. We've cleaned it out already. Got most of the dirt and grime off using the surface cleaner and the brake cleaner. So the next step here again is the sandpaper. Get in there, clean that stuff out as best you can. Again, just the cleaner the motor is, the better it's going to work. And if you get rid of this now, you don't have to worry about corrosion down the road, or at least not as soon. So again, notice I'm just focusing on the fins there. Those had some, again, I don't know what the heck was going on with those fins, to be honest. Given the environment this was in, it could be anything. It was an industrial setting there with a lot of dirt and grime and who knows, metal particles going around. It was just, it was being used hard, and it shows it here. But again, we can bring it back to life again with the bearings we're putting on in right now. Again, just cleaning off the fins and the end bells themselves, getting that corrosion out using a little sandpaper. Take your time on this like you do most other parts in this motor, and it'll be fine. Just do a little scraping here and there, and you shouldn't have any trouble at all. We'll just go on to the next section now. Okay, let's talk about bearings for just a moment here. Right there I've got a rubber sealed bearing. You're going to want to use sealed bearings almost certainly with the motor, whether it's rubber seals or metal seals. Notice how it turns. It's not freewheeling. Of course, that's because there's grease in there. It moves fine, but it's not freewheeling like this one. Look at that old grease coming out of there. That spun it out long ago. Notice how that's just spinning like crazy. That's a sign of a dead bearing right there. Also, the other one here, the other old one, a little harder to see because of all the grime, but it's also spinning like crazy. I think I've got the other one again. Both in this particular model, the bearings are different size from one side to the other on the rotor. Sometimes they're the same size, sometimes not. All right, well, the next question you've got probably is, well, we've got the bearings. How do we get these things onto the rotor? Well, right here you see the answer. We've got a couple of pieces of galvanized pipe, one of which is 3/4 inch, and the other is 1/2 inch. And just so happens they fit very well, in most cases, on the inner rings of the bearings. You see that right there, that inner ring there that it goes on? That's where you want to hit the thing onto. You don't want to hit it on the rubber seals because you're going to damage the bearings. And that was a 3/4 inch. This is the 1/2 inch. Just a perfect fit there. I'm sure that's not by accident. So you tap that in. That inner ring is called the inner race of a bearing. So you tap it on there gently using a sledgehammer or something like that. Gentle taps with a sledgehammer. You'll get the bearings on no problem at all that way. Now, one thing you can do to help put the bearing on the rotor is to expand the inner race, make it larger. Now, how would you do that? Well, heating it up. That's one way to go. That expands the metal. Good way to do that? Put the inner race on top of a light bulb like you see here. So this is, I think, a 75 watt bulb. Turn it on, let it heat up for about 5 minutes. Let it expand just enough so it slides onto the rotor. It's an old trick. All right, time to put these bearings on the rotors. One thing I did was I took the rotor and put it in the freezer for a few minutes, about 30 minutes actually, to cool it down. That way the metal cools and contracts. Meantime, the bearings themselves, which are very hot, which is why I'm wearing welding gloves, those have expanded. So cold rotor, warm bearings makes it easier to put these things on. And notice I've also got all my supplies laid out. You want to do this as quickly as possible so that the rotor doesn't heat up and the bearing doesn't cool down. Now notice I just wiped a little condensation off that rotor because it came out of the freezer. And notice here I can just put this bearing right on. I didn't need to tap it on at all. Again, that's because the rotor was cool and the bearing was hot. No need at all for any of that. But if I had to, I'd get my pipe there lined up like I'm showing there and just tap it on gently. That's, I think, a small 2.5 pound sledgehammer. Meanwhile, the other side, not quite as good. Notice I've got a block down at the bottom that I'm going to hit with. I don't want to hit this against the cement, but notice here the bearing won't quite press on, so we're going to have to tap that thing on. So we got our pipe there. We put it over the inner race like we talked about before. And again, notice it's on a wood block down at the bottom. That way I don't mess up the threads on the other end as I tap this. And there we go. I just tap it gently and take a look periodically. No need to go crazy. You got time to do this. Again, the bearings are hot, which is why I've got these gloves on. Tapping it on carefully, gently. You'll get there. A little more progress. Again, making sure that you've got that pipe lined up on the inner race. Making sure that the other end of the rotor's on that wood block again, so you don't hammer this on the cement and ruin the threads. So we just line that up nice and easy. Again, you've got time to do this. And just gentle taps. Nothing crazy. Again, 2.5 pounds of sledgehammer there. That bearing's going to go on. And there we go. It's on there now. Looks good. Feels right. No binding as you spin it or anything like that. So I think we're in business here. So that's great. So the bearings are on. Looking good. Notice even after it's on, I can't pull it off again because the bearing's now cooled down and the shaft is heated up. So it's a press fit and it does its work very quickly. It's looking good. I think we're in business. Let's go on to the next step. Okay, we're just about ready to put this together. However, I want to take a second or two to talk a little bit more about that centrifugal switch and how it works. Notice I'm pressing against the little disc there that spring activated, and notice those weights at the end of it. What happens is, of course, the bearing goes in there into the centrifugal switch. And it's hard to see here, but notice when it goes in, by default, it's going to press down on that ring. And when that presses down, there's a circuit completed to the start capacitor. Now, as the motor starts to spin up, and I'm, of course, pretending to do that right here, what happens is that little disc you see right there that I'm pressing up, that gets pushed out because of the weights at the end. And when that happens, of course, the ring, which was down in the closed position, then pops up, springs up in the open position. And then the circuit's broken, then the start capacitor is taken out of the circuit, and then the motor's running on its own. Just a quick FYI in case you were wondering about how that worked. All right, we're ready to put this back together. Let's get our tools, materials lined up. We've got everything there. We've got the gloves on. We've got our ratchets. We've got our end bells. The rotor's all set. Bearings are on there. We've got our through bolts all there. We've got a soft blow hammer there to tap the end bells on. We're just going to knock them on like that. Nice and easy. Nice and easy. You don't have to use something with a non-marring surface like that, like a dead blow hammer. Now, one thing I want to point out, when you put this together, don't make the mistake I did once and put that centrifugal switch so it's facing backwards against the end bell. Make sure it's out there like that. Otherwise, what's going to happen is the start capacitor is going to be energized the whole time and it's going to burn out because you don't have a chance for the ring is pressed against the other side and it never ends the circuit, and that's not good. And you can kiss your start capacitor goodbye after about 10 seconds of that. Don't ask me how I know. Now, also, we're going to take these wires. Remember, this is important. Plug the wires in the way they were when you took them out. Originally, when you remember, this is why you want to document how the wiring went, because this wiring is pretty enclosed space. You're going to have a rotor going through there. You don't want the rotor rubbing against the wires, spinning them out of control. You got to make sure they're tucked in the right position. Again, that's all part of the documentation that you did before. So now we're putting the rotor in nice and easy, making sure that all the wiring's there. We're not pinching the wiring as we put this together. Again, taking our time, making sure that, we have a wavy watcher at the bottom of that end bell. So we'll put that in, make sure that's in properly. Take a close look, get the fitting in there just right. Make sure that tab is at the top, looks good. Same thing, we want to orient this so the fins are facing down. That way any water that hits at the top is wicked away. This is called an open drip proof motor for that reason. That's why, because the fins are there. Any water that hits is going to be wicked away from the motor. If they're upside down, they're going to be wicking water into the motor from the fins, which is not what you want. All right, so now we take our dead blow hammer. We do some gentle tapping. Again, nothing crazy here. We're just going to get this thing on nice and easy. One side to the next. We check, make sure we've got our tabs lined up. Looks okay. We'll take this hole there and just tap on the other side. You guys get the idea at this point. We're going to tap at different locations. This is, I think, is a 4-pound dead blow hammer. And again, just slowly making sure we've got that all lined up there. And we'll just, we'll rendezvous in just a sec and continue on when it comes time to put the through bolts in. Okay, we've got things lined up. The holes are there. Now we start threading through the through bolts like that, and we start putting the nuts on. Nice and easy here. At this point, we've checked, made sure that the tabs are lined up at the top. When that's the case, then the through bolts shouldn't have any problems going through. These are long suckers, a foot long or so. You might encounter little bindings you push through originally. Just nudge it through, make sure, take a peek, make sure you can see daylight from one side of the motor to the next as you look through the through bolt holes. And we're just putting the nuts on there, no big deal. We'll get this thing in, then we'll start tightening up in just a second. Okay, great. We got all the bolts in. The nuts are on there. Now let's start tightening this thing up. Again, got a couple of ratchets there. We're going to go slowly here. We're going to tighten them down in progression. So we'll do a little torquing on one bolt, then to the next, go to the other guys, and we'll do this in stages. So we'll do about 3 stages here. You don't want to tighten it all down at once. You want to make sure nice even torquing on each bolt as you go through. That way the end bells are pressed in evenly and there's no binding. This is, this is pretty close fit stuff here. If this isn't on tight, the rotor is going to bind as you turn it. There's very little clearance inside this motor, inside any electric motor, not just this one. And so you want to do this in stages to make sure that things are still spinning freely when you turn the rotor at the end. Again, just back and forth. You notice this is like our second time through. I'm going to do a series of these. No need to rush. Again, easy stuff. Take your time. I've said that many times. I mean it. And this is another time when you want to take your time. Go through. So you get the idea at this point. We're going to go down, tighten this up. At the end, they'll be pretty tight. They won't be, they won't be iron tight. You don't want to go crazy tightening this stuff up. But, a nice, good, snug it down fine. And again, just keep going back and forth, torquing it down, each bolt individually, evenly, and you should have no trouble. Okay, really quickly, I just want to show how you connect the start capacitor afterwards. We've got the case there. We've got the start capacitor. Still got that crack. By the way, I ordered another start capacitor to replace this one after the video was done. Again, it cost me about $10, $12. No big deal. Now, the key with these guys is there are 2 posts on that start capacitor, 2 sets of posts. And every motor is going to have probably 2 wires coming out of the top. As you see there, a black and a white one, maybe different colors on your motor. Each wire goes on a separate post. It doesn't matter which post. Those 2 posts are identical as far as functionality goes, but the wires have to go on different ones. So, for instance, I got the white one there and the black one on the other one. And again, it doesn't matter which post they go on, but they can't go on the same post. That's the only caveat there. And once that's done, you just basically fit it in there and then just put it on there. We've got the 4 screws that held the case on there. You can see me wriggling around here trying to get the best fit. These things are usually a tight squeeze. You just want to be careful you're not pinching the wires as you put it together and put it on there. I'm doing a little test fitting here, just jiggling around, making sure everything's lined up, making sure the capacitor's in there tightly. You get the idea. Once you put it on there, then get the bolts out and away you go. All right, the moment of truth. All our hard work, hopefully, coming to fruition. We've got the bearings installed, end caps are on. The rotor spins nice and freely, no binding or anything like that. Start capacitor is installed. Let's give this thing a whirl. Hopefully it doesn't catch fire. All right. 3, 2, 1. There we go. Spinning nicely. How's this doing? Nice and cool. No heating, overheating, or anything like that. Looks good. Let's take this out. Unplug it. Looks good. Notice how quickly that shaft stops spinning. That's a sign because the bearings have grease compared to what we had before when the thing kept spinning for, 20, 30 seconds at least after you unplugged it. So we're in business there. So that's good. How's the motor feel? Nothing warm, nothing binding. Now there was a little click there at the end. I want to play that. I want to show you guys that again and explain what that is. Just a sec. Here we go. Okay, I'm going to unplug it and listen closely here. Listen to this. Now, I hope you heard that click. What's going on, of course, is those the inertia switch. The 2 copper rings are pressing back together again as the switch is closed. That completes, again, the circuit to the start capacitor here, so that when you plug it in again, this thing's energized. And when it spins up, after a second or 2 or even less, once this gets its job done, those things will then disconnect and no more juice goes to the start capacitor. So again, the capacitor should not have any current energy flowing into or out of it after the first initial startup. So there's that. But this is looking great. I think we've got it all set up. Again, I used a Baldor motor. Almost any electric motor, 1/2 horsepower, 1 horsepower, 1/4 horsepower, with a start capacitor is going to work the same way as this. So hopefully you're in good shape to take your own project and run with it. So thanks again for sticking with me through this video series. I hope you make use of it. And that's it. I hope you enjoyed the video. I hope it proves useful to you just as either general knowledge or something you can apply to your own electric motors. Thanks again for sticking with me through this. I hope it goes well for you in your own projects and hope to see you soon.